All right, we are going to be making an inverse statement based off of a compound interest formula. And if we look at part B, it says, what function can calculate the time it takes for any principal? And let's go back to the original problem there. It says a CD account that had an annual interest rate compounded monthly of 5% closes with a total of $2,400. If the account started at $2,000, what function can calculate the time it takes for any final principal? So when we look at this problem, the $2,441 doesn't even matter, because what we want to do is create a formula that represents all of it. And since we're going to be representing the time based off of the final principal, we're going to be actually writing an inverse statement in this case. So let's start filling some things out and working on it. So we don't know what the final principal is. So instead of putting p of x there, I'm just going to write y, because we don't know what that is. We know the initial value is $2,000. And then we have 1 plus the rate, which is 0.05. We're compounding it by 12. And then we have a compounding of 12 to the x. Now, x represents time, and y is going to represent our final principal. And since we are going to be making a function for time, we're going to be solving for x, which means that we're actually looking for the inverse. Okay. And so we'll be writing a p inverse of x statement. So let's go ahead and do that. First thing I'm going to do is divide by 2,000. So let's get rid of that 2,000. We get y over 2,000 equals to 1 plus 0.05 over 12 to the 12x. And now, going back to what we've been working on a lot lately, here's our value. Here is our base. And here's our exponent. Okay? And because we have a value, a base, and an exponent, and nothing that's added or subtracted from that base on the outside of that piece, we can go ahead and write our logarithm statement. So that's what I'm gonna do. I'm gonna write log, which is a base of 1 plus 0.05 over 12, a value of y over 2,000, and that equals to 12x. Note though, hey guys, we aren't done yet. We still got to divide by 12. So I'm going to divide this whole entire piece by 12. This is going to cancel, and that will give us our x statement. So I'm going to go ahead and just transfer it over to a p of x statement right now. So our p inverse of x statement, which is going to be log, parentheses, 1 plus 0.05 divided by 12. With x over 2,000, all divided by 12. Okay, and remember that since we flipped everything out, that this is going to be our final principal, and this is going to be the statement for time, because this is an inverse statement. Let's go over to Desmos. We can verify that they're inverses, because that's always a great thing to do. And as we do that, remember, I'm going to go ahead and name it, just give it another function name. And I'm going to put in the log first. I'm going to come in, I'm going to go function, down to log A, and then I'm going to put that, I'm going to come back to this d over dx right there. And I'm going to type in 1 plus 0.05 divided by 12. And then I'm going to erase the rest of that statement. That'll put that in the base for us. And then I'm going to type in x divided by 2,000. And then I'm going to put that whole entire value in there, divided by 12. Now, when I look at this graph, okay, I'm going to come back to home. I'm going to look at this graph, and then I'm going to try to zoom out as square as I possibly can, because that's going to allow us to see if they are inverses. And remember, inverses are reflections, and they are reflections right over that beautiful line, y equals to x. And we have that. It looks like the red line is a mirror image of the purple line, or the curve, or the purple curve is a mirror image of the red. And we can also come over here. And remember, I like to go ahead and say, let's do the compositions of P of X and H of X just to verify. Why not, right? P of H of X. And I'm going to tell you what, if that Y equals the line of X line glows up, we have two inverses that are going to match up really nicely. And that's what we've got going on right here. So we found the inverse correctly, which gives us an equation that will calculate time based off of the final principle every single time in this situation.